In this video, we are going to discuss about idempotency, and we are going to take it within question which is asked in almost every interview for software engineering across various levels. So it's not fixed on a one specific level, but in 2026, it's more or less asked everywhere. It's a part of a API, REST API questions, interview question. The interview may ask, like, the interview may not ask directly, like, what is idempotency? He will ask you something like design a idempotency handler, or he may ask you the characteristics of a post request or a get request or a put request. So the questions can come in these three ways. So the most classic question that is asked was, what is the difference between get, put, and post request? So idempotency is one of the main answer for such question. But now let's understand what is idempotency really is. Idempotency helps to take the duplicate request, and it enables client to safely retry an operation without worrying about the side effects of the operation it can cause. So which in short means that we don't want something duplicate in our request. For example, like let's say we are doing a post call. We want to do a post call, and post call we know is a call that creates something into the database. So for the post call, we have a database in the background which have some data. So an entry and such example could be create profile, or it could be add an item into the cart. Now when you are adding an item into the cart, that you don't want to make duplicate entry of the same item. You want to increase the quantity though, but not the same item as a separate entry. What this means, we don't want to duplicate things. And what does idempotency does? We want to do an operation. It makes sure that operation can do multiple. And what does idempotency does? It makes sure that an operation that we are doing do not create multiple entries in the data. Now there are some requests that are idempotent by default, and such are get. All of these three are idempotent by default, because when you want to when you are trying to get some information, whenever you are doing a get request, you get the same item back, right? You don't actually you are not creating an entry, you are requesting some information, and every time that information is coming back to you. Same is for delete. Once you delete something, it's just gone from the database, it's not there anymore. Once you have deleted something, you cannot re-delete the same item. So that's why it's idempotent. And same does for put. Put is to modify some information, right? So whenever you are modifying something, you use put request. Okay, so put request is also idempotent by default in nature, because it is used to modify a resource. So a put request is also idempotent by default because it is used to modify a resource. It is not used to create a new resource, it just modifies it. So there is also one important question, like what is the difference between a post and a put request, because both are doing some change into the resource. So what you will say post is not idempotent by nature, put is idempotent by nature. Post is used to create a new resource, and every time it will create a new entry for the resource. So duplicates are possible because you will get a new ID in general. On the other hand, request can only be done on the existing resource. So the resource should exist in the database already, otherwise it will fail. It replaces the whole resource, or it updates the resource, but it will not create a new resource. So this is the nature of put request. Post is not idempotent by nature. Okay, so what we have to do, we have to actually make it idempotent. So these all are idempotent by default, and this is not idempotent. Post is not idempotent. So we have to make it idempotent. Now let's take an example of a post request, which is a client and there's a server. And what we are doing a post call. And what we are going to do, we want to send 10 rupees. We want to send $10. And now this is a DB here. Now let's say we did this call, and for some reason this call gets stuck, or there's a problem with the server, or you can say there's a problem on the UI, due to which you clicked multiple times on this post request. So what will happen? Since it's not idempotent by default, it will do these calls multiple times. So multiple times these calls will be done. Multiple times you will be sending $10 to everyone, to the person, sorry. So every time $10 will be deducted from your account, even though there should be only one deduction, but due to its nature, you will be getting deducted with $10 with every single call, because this is how just its nature. So here the payments will be done multiple times because we have the duplicate request, and we need to solve this. We want to make this idempotent ourselves, and how we will do it? So there are side effects of this non-idempotent call, and there are two types of side effects for it. And what are those? We have sequential and another one is parallel. Okay, so now let's see how actually duplicates come. So when we said there is a problem on the UI and you did multiple clicks by mistake for the same operation because you thought like, okay, there is a possibility that I have not clicked it, or you didn't see the bar moving, that's why you thought it's some issue and you clicked it again. Now let's look at more realistic example at how duplicates can come. How duplicate can come. We will take the same similar example of a client and a server. This is client. Let's put it right here. And now this is server. Now you did a call, post request. You called. You said add an item. So basically, this is a shopping website where we are adding some item to the cart. So we did a post request, add an item to the cart. But let's say due to let's say due to traffic, you get a time out for the client on your UI basically. So what will happen? Server is still processing, but there is a timeout for client. Now there is a timeout for client already. Now what will happen? An automatic retry will happen. So that's what generally happens on the UI side whenever you are working with a web application. So you add an timeout retry for the same. Now what we have to do, we have to handle this specific scenario. This retry part is the most important part here because we have to handle this scenario to make this post call idempotent. Okay, so let's see what are the steps over there. This was the first call that happened as a post, and on the second step we got a timeout, and now the third is we are retrying. Now it can either repeat or it may pass here, but there is a request already on the server present which is processing, so it may again put the server into the processing mode and it can continue until your number of retries. Okay, so this is what is sequential scenario that we just saw. Now next is the parallel scenario. Okay, all right, so same, we have a client, we have a server, and this is server. We did a post call and another same call at the same time. What could be the reason? It might be the refresh, it might be multi-click as we were talking in the start. So right now server has both of the calls and it process it start processing both at the same. So this is, let's say, a duplicate. We have to handle this scenario as well. We have to take care of this specific scenario as well. Let's look at how we can handle this scenario. So now we are going to talk about approach or idempotency handling. Whenever we are talking about uniqueness of a request or uniqueness of any entry, what is the first thought that comes up in our mind is using IDs, because IDs are generally the only way to make something unique, right? In database also we use foreign keys, we use primary keys, and the reason to use those keys are uniqueness. We want to make sure that for that specific key there is only one entry. We may modify the entry but not the key still. So here same approach we are gonna follow, which is using idempotency, which is something unique. It is something unique to make sure that we are able to recognize a request. It can be anything. It can be any long key, single. It can be a string. It can be anything, but it has to be unique. So by code level, we usually are given something called UUI, Universal Unique ID, is present in almost every coding library. So we are gonna utilize that. Now, where we will use it on the client side or on the server side, we are going to look at that as well. We are calling it as arrangement client and server. Client should generate idempotency key because client is sending the request, so client should generate the idempotency key. Now the second is for each different operation, new idempotency key should be generated. Now we are gonna look both of these, like how we are gonna use them. So first is almost clear that client is responsible to generate an idempotency key for each request or an operation, we can say, but we will call it a request. So here client is the one firing the request, post request, and server is the one who is processing those requests which as an operation. So now we are gonna look into the flow, how the idempotency key solve this problem. How does it solve the problem? So we are gonna create a whole flow chart to understand this solution and how the idempotency key solves our problem. So it's going to be very interesting, and definitely we will be learning more with this. Okay, so now we are going to look at the first scenario where client should generate. Okay, so this is the flow when client is generating the idempotency key. This is the post request and operation is add item to a cart. So this is an original request, first request. Now what will happen? First step would be the client will generate the idempotency key. Now this is happening before actually firing the request to the server engine. So this is the first step. Now what will happen here? The idempotency key will be set in the header, okay, in the request header, and server will be called. This is the second step. Now here server is receiving the request with the idempotency key. This is the third part that is happening over here. So now when this server is receiving this request with idempotency key, it will actually check the request header that whether the idempotency key is present or not. So if it's not present, what it will do, it will throw an HTTP 400 bad request, calling it as a validation error. Back to the user will see this error message in his response. If idempotency key is present, which means if it is present, then server will be called and it will read it from the database, because it's a unique key, right? If it's not a unique call, that key should be kept somewhere. It has to be stored somewhere, because we cannot keep it in just in memory for a like short period of time. We will look at that as well, but it has to be stored somewhere for reference purpose, that we actually know that is this key really unique or it is already present. But it's not a latest request, which means it's a duplicate request, and we can successfully reject it, because we can say, okay, we have already received a request, we don't want another one. Okay, so this idempotency key will be read from the database if this is present. So if it is not present, what it will do, and db entry will be created for this idempotency key. So this is a database for storing the idempotency key. So if it is not present in the database, so it will actually create a new entry for the same. So we can call it as this is a fourth step. Now this is the fifth step, and once the entry is created in the database, the operation that was requested by the client will be performed by the server. So now the seventh will come it as, if operation is performed successfully, then you will get the response as success created, which is 201. This is simple. So this was the first entry. Let's talk about the life cycle basically. So this idempotency key that we are creating will have a life cycle in database, and what it will be, what will be the phases. It would be created, it would be acquired, which means this idempotency key is latestly created, so it will be created, and then acquired, which means a process is already using this specific idempotency key in a separate instance. So that will again safeguard us, it will safeguard us from doing the duplicate it will safeguard us from repeating the now it will safeguard us to process the duplicate request, or the second it could be as also consume, claim, or use, which means it will be created first, then it will be acquired, then it will be consumed, claimed, or used. Basically it can be anything out of these three. Means this has been used already, so it is a duplicate request, we will reject it. This will be the validation part. So just I'm just putting a note here just for the more reference. Once ik is consumed, claim, let's say, then the same idempotency key cannot be reused. So this was the flow for a client creating the idempotency and making the post request as idempotent from the client. Now second is, let's say due to some timeout, client is sending the duplicate request. Internally DB has already done all the things we saw in the diagram above, but due to timeout we are getting the duplicate request. So how it will perform? So what we are looking at is a scenario where this system that we created handles a duplicate request. Right now we did a unique request, the client is creating the idempotency key and till the end, but now what we'll see that we are getting a duplicate request, how this works. So we are going to look for another flow. Okay, now this is the scenario where client is going to send a duplicate request, and this is we are talking about sequential right now, not in parallel. We are going to talk about that as well. Now let's say due to some problem or multiple click one by one, not at the same time, or let's say after a retry we are sending a duplicate request. What will happen? So what's happening here is, here the same idempotency key is being used after retry by the client. So here duplicate ik is sent, idempotency key is sent. Now the third step would be validation of that idempotency, and what was that? It will check ik present, it will read this idempotency key. Now since that idempotency key is already in the database, for now basically we are gonna follow this above one. It will gonna create it from the database. If it's not present, then it will create an entry and all. But here, since it's a duplicate request, that specific idempotency key is already present in the database, and what it will do, it will check its status. What is the status of this idempotency key? Now if the status consumed, means if the idempotency key is already consumed, which means the previous request has already been completed. So we are gonna send a 200 we are gonna send a 200 response and it will say something, previous request completed already. But if it's created, means it's not consumed, it's just created, means it is being used by someone. It is not consumed, but it is being used. So we said created and acquired, consumed, claim, and used, right? Consumed means the status is done, work is done. Created means someone has created it and it's using it. So it's a conflict. So we are going to send HTTP 409 saying it's a conflict. Now there might be a question in your mind like, okay, we get it that this is safe, but what about multiple instances trying to read at the same time in the database, and still our problem is not solved because even though we have different idempotency key, but still we are able to hack it due to, let's say, multiple requests at the same time, or multiple requests reading about the same instrument, sorry, idempotency key at the same time. So here this operation after validation is happening all in the database. So this is we are calling as critical section, and to safeguard this we are gonna all of this under a lock. So we are gonna put a lock on this, and we are gonna call it as critical section. This is very simple. That's how database also works in general. Whenever you are trying to update something and there's a potential of updating a record or a row, you put a row level lock on a database. It happens automatically. If it's not happening, then you have to do it manually by changing some configuration. So here, if idempotency key status is consumed, we return 200, means previous request already been completed. If it's created, we return 409, means there is some conflict for this specific idempotency key as we discussed. Now let's talk about what about the parallel request. It can be a follow-up question from the interviewer. Right, what about parallel? Okay, this works for sequential, and what will happen about parallel? If client sends two parallel post calls, then all the operation will happen parallelly, right? Creating two resources in the end. For the solution, what we already did is we will lock our critical section, which will be starting from this specific part, right? We discussed about it already. You get it? I just wanted to talk about an additional question. So this is solution for the sake. But you may ask, like, what locking mechanism are we using here? We can use, let's say, sync or semaphore on the idempotency key. We will gonna discuss about semaphore in future, but you just know about sync, right? Synchronized block in Java as well as it's a concept. So we can use those kind of locking mechanism, or there is also called mutex as well. So with this locking, only one call will create a resource, and second call will go through the idempotency key already present. Now another question would be, what if we have separate server or location instead of same server? It's possible. We might have multiple data centers in different locations. Then how we are gonna solve this problem? So there is a solution for that, is using use of cache, and cache would be also a common cache. Let's say these are multiple servers and this is a shared cache. So these servers will be connected with the same cache for idempotency key. Alright. So this solves our problem of having the separate servers in multiple location, or in general having multiple instances of the server. Once they are connected with the same shared cache database, the synchronization become near real time because cache is the fastest memory at the moment. So whatever is the status of the idempotency key at that point, these server will get it. So I hope you understand about idempotency and how can we design idempotency handler. Thank you. See you in the next one.